Tuesday Scholars, today we are going to continue studying our connections between multiplication and division, especially looking at how we can use arrays to solve and create multiplication and division equations, but also how to solve those kind of tricky problems like find the missing factor or what unknown number can give us sort of the answer that we need, which are some of the questions that I noticed were really tripping people up on the past couple weeks of quizzes. So let's rock and roll. So we know that there are some connections between multiplication and division. We know that division is the opposite. It's the opposite operation of multiplication. For multiplication, we know that we are combining equal groups to equal a product. In division, like we talked about yesterday, we are splitting a total into equal groups to figure out how many go into each. Just like we talked about, it's almost like I made this on purpose. When we divide, we split into equal groups, and when we multiply, we take those equal groups and we combine them together. So that's exactly what we're doing. That's why they're opposites. And just like we can use addition to solve some subtraction problems, we can use multiplication to solve some division problems, and vice versa. So let's see. I have an array here. I don't know how many total objects are in this array, but I know that by finding the dimensions or the rows and columns, do your arms with me? Show me rows. Show me columns. Nice. By finding the rows and columns, I can solve for how many are in here. I can also think about it like a division equation. So let's review sort of what we were talking about yesterday by creating division and multiplication equations to match this array. So what I draw on here, I would like you to follow along and draw on your paper. But I really want our eyes focused. We're going to do blue and orange because, of course, wahoo wah. So I'm going to count my rows here. 1, 2, 3, 4, 5. So I know that these are 5 rows. Now I'm going to count my columns here. I'll do it in a darker color so you can see. 1, 2, 3, 4, 5, 6, 7, 8. So I know that there are 5 rows and 8 columns. What multiplication sentence can I write to show, multiplication expression can I write to model this array? I'm going to give you 15 seconds to write it on your paper before I write it up here. When you hear the sound effect go off, that means you know you should be done. You have about 5 more seconds. And that is your time. Kind of sound a silly sound there. So that was your time. I hope you wrote something to the effect of 5 groups of 8 matches. Those are the dimensions to this array. Now we can use this array to also solve what 5 groups of 8 actually equals. I'm going to do it by skip counting along the bottom, which you can absolutely do just by skip counting on your paper. So I know that these are these are columns of 5. In each of my 8 columns, I have 1, 2, 3, 4, 5. I know skip counting by 5. This is a lot easier than skip counting by 8s for me, so I'm going to skip count by 5. So I'm just going to skip count by my columns. So I'm going to go 5, 10, 15, 20, 25, 30, 35, get my 5 up in there, and then 40. So just like we did here, we know now that 5 groups of 8, 5 times 8 equals 40. Now, I can also think about this like a division equation. So I'm going to do that in another color to make it separate. I'm going to do it in red. So I know then if I have a total of there are 40 tiles in the middle of here, right? So I know if I'm going to write a division equation, it's the opposite of multiplication. So I'm going to start with my total. In this case, I have 40 total tiles. And say I want to split them into my rows first. So I'm going to say 40 split into, and I have 1, 2, 3, 4, 5 rows. So split into 5 rows equals, and now I just need to see how many are in each row. If you're like, Miss Cupp, it's just the number of columns we have, you're absolutely correct, right? Because in each row we have 1, 2, 3, 4, 5, 6, 7, 8. So if I have 40 tiles, just like I did here, I want to split them into 5 groups. If I wanted to go, I get this one, Buffy gets this one, my mom gets this one, Kaylee gets this, and my dad gets that. Each of us would get the 8 total. In this case, they kind of look like oranges. So each of us would get 8 oranges if we had 40 total oranges. But I could also write this another way. Just like how I can reverse some of my factors when I'm doing multiplication, I can also think about this. Well, what if I wanted to break up these 40 total oranges into groups of 8? What if I wanted to split them by my columns? What if I had 8 friends I wanted to share these oranges with? So then I could think about this as, okay, so now instead of counting down my rows, I'm looking here. How many are in each group of 8? So I can think about this as, what are my 40 oranges split into 8 groups? How many would everyone get? They would get 1, 2, 3, 4, 5, right? They would get my rows, because this person would get 8 group, or this person would get 5 oranges, this person would get 5 oranges, this person would get 5 oranges, so on, so forth, until we got all the way to 8. So in this case, if I wanted to split 40 into 8 groups, I would have 5 in each group. So we know for every array, we just wrote 3 different equations to represent this array. I can also use this to help me solve unknown factors by using my relationships in these equations. For example, I know that 40, my product here, is always going to be my start number for my division equations. So if someone gave me this equation and said, this equation represents this array, what division equation would I look for? I'd be looking for division equations that start with my product, that start with my product, because my product tells me I have, again, 40 oranges total. Now, knowing these relationships can also help us when we see problems that might look something like, oh, I don't know, this, where it says like, fill in the blank or find the unknown factor, like say there was a box here or something, 5 times what number equals 40? Well, if we know our division equations here, that 40 split into 5 groups equals 8, then we can actually plug that number in right there. Because if we read these like mathematicians, right, this says 5 groups of 8 equals 40. Using our knowledge of division, we know, yeah, that's true. 40 split into 5 groups equals 8 in each group. So we can just plug that in. That's why it's super useful to use arrays and to use our knowledge of the equations that we can make off of arrays to help solve these types of problems. Let's continue. For example, let's look at this question here. How can I use this array to find the unknown factor in 4 times, or 4 groups of how many equal a total of 28? So let's double check and look at our dimensions here. So I notice that there are 1, 2, 3, 4 rows. So I'm thinking, okay, this array is currently grouped into 4 groups. There's 1 row here, 2 row here. You can actually see them because they're outlined in gray. If you can't quite, you can go ahead and expand this video to make it even bigger to prove it. So I see here that, so like I said, we have our 4 groups here. Now, let's just double check that this does indeed equal 28 by counting along the bottom. This also could double check how many groups we have. So how many are in each, not counting along the bottom, sorry, counting along the side. How many are in each group? We have 1, 2, 3, 4, 5, 6, 7. So here is 7. There is another 7 here. I know 2 groups of 7 is 14. 7 plus 7 is 14. Then we can go 15, 16, 17, 18, 19, 20, 21. And then we have our final group, our 4th group. 1, 2, 3, 4, 5, 6, 7. We know that 21 plus 7 is 28. So we've confirmed here that there are indeed 28, I believe these are 1, 2, 3, 4, 5, 6, these are octagons inside, fun fact, get some geometry knowledge. So there's 7 octagons for a total of 28 octagons, 7 octagons in each of our group of 4. So we know that 4 times 7, 4 groups of 7 equals 28, because we have 28 total octagons inside here. We broke them apart into the 4 groups outlined by these gray outlines here, and there are 7 in each group. Now, what number sentence did we use to actually solve our work? So let's think about it. What did we actually do to solve here? Well, we counted our groups, our 4 groups. We counted that there were 7 in each. You can also think about, well, what do? We knew that there was 28 total objects. We knew there was 28 octagons here. And we were like, okay, so we need to split these into 4 groups in order to figure out how many go in each group. How many were we going to put in here? And so what we did was we went ahead and did that. Or actually, I did that for you because I made the array. You're welcome. And we saw that there was 1, 2, 3, 4, 5, 6, 7 in each group, which was true. In each of our 4 groups, there were 7 for a total of 28. We can also think about it like division to help us solve the unknown factor here. So that's what I was talking about yesterday when I was saying how useful these arrays are. When we get really good at arrays, we can use them to solve all sorts of problems. Today, we're going to be using them to not only create equations, but also to solve these types of unknown factors. Let's get rocking on your guided practice. All right, so let's look at question 1. Make sure your scratch paper, which I hope was already written on since you were following along on your paper as I was doing my work, but just in case, make sure your scratch paper is out and you've labeled this question 1. So it asks us, what number could you put in the boxes to make both statements true? So I'm going to look down below, and basically what this is asking me is, what number can I put in both of those boxes to make both of those statements true? So it says there are 20 dots divided into 4 equal rows. That means there are how many dots in each row? Let's count. 1, 2, 3, 4, 5. Double checking. 1, 2, 3, 4, 5. I can also just look. They're nice even rows. So that means I know that I could put a 5 in this box. There are 5 dots in each row. Now it tells me, so that means 20 split into 4 equal groups equals 5 in each group. Let's double check. Turn this into a multiplication equation. We know that I could read this as, is it true that 4 groups of 5 equals 20? Let's check. Let's skip count by our 5s because that's pretty quick and fast. 5, 10, 15, 20. I counted 1, 2, 3, 4 times. I did indeed get to 20. So yep, this is true, which means, yeah, if I have 20, in this case, green circles, split into 4 equal rows, I'll get 5 in each row, which I know because I skip counted on my paper. You could have also skip counted here. 5, 10, 15, 20. So yep, the quotient of 20 split into 4 rows or 4 equal groups is 5, or 5 in each group. Like I said, arrays can be super useful. So you would type 5 in here and move along. Now it wants us to write a multiplication equation to match the array. That's what's so useful about always checking our work with the opposite one like we did here. We already built this check in. So for this, I know I'm just going to write 4 groups of 5 equals 20. I also know that I can just look at the array up here and look at my dimensions. I know that this is 4 rows, 5 columns. So I could just think about this as, I'll do it in another color. Do blue. This is 4 rows times my 5 columns equals my total of 20 tiles. So I can use that information. I can use the fact that I know this is a 4 by 5 array that equals a total of 20 and type that in there. 4 times 5 equals 20. See? Arrays. They're making life super quick and fast. All right, let's check this guy out. Again, What number could you put in the box to make both statements true? So what you're going to do first here is read the statements. There are 35 dots divided into 5 equal rows. There are blank dots in each row. So it's your job to find out how many dots in each row. And then once we do that, we know we can solve that division equation. I'm going to give you about 1 minute to try this on your own because we just did one exactly like this. So I'm going to give you 1 minute to try this on your own. When my timer goes off, we will review. Go. Remember, you're trying to figure out how many dots are in each row and then using that information to solve your division equation. About half of that minute is over, so you've got 25 seconds left now. If you've already finished answering this question, go ahead and answer the question below it. 10 seconds. And that is our time. Alrighty, let's rock and roll. So there are how many dots in each row? If we have, this is 35 dots divided into 5 rows. 35 divided into 5 groups. We want to know how many in each group. I hope you counted 1, 2, 3, 4, 5, 6, 7, and that there are 7 in each group. I hope that with any extra time, you knew then that this was our answer and that you checked your work maybe by using our multiplication strategy. So did you double check that 5 groups of 7 equals 35? Maybe you were like me and you actually just counted and you said, okay, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Then you know that 21 plus 7 is 28. Maybe you had to use these and go 29, 30, 31, 32, 33, 34, 35. For a total of 35. And yep, that was correct. Maybe you thought smarter and not harder, and you're like, wait a second, I can flip those around and do 7 groups of 5 and went 5, 10, 15, 20, 25, 30, 35, and also got it that way. Another great way to check. However, what is the multiplication equation that matches the array? How many rows by how many columns? We know for question 4, we can think this was my number of rows. That was my number of columns in my array. So I know that that does indeed match for my multiplication equation. So I would write 3 times 5 equals, not 3 times 5, Miss Cuppernull, say silly Miss Cuppernull, 5 times 7 equals 35. So again, what we've done with these 2 problems is we looked at how we can use arrays to not only write and solve division equations, which is what we did here, but also how we can use our multiplication equation, our knowledge of rows and columns, our knowledge of groups and amounts in each group to correctly solve these. All right, now let's get to that missing factor that I've been talking about. So we know that we can use arrays to solve equations. Now let's just go that final step and find the missing values. So let's look at this question 5 here. I promise you it's going to look very similar to what we've just done. Now we're just piecing the puzzle pieces together. So it says use the array to figure out the missing factor that makes both equations true. So I have this array here. Below it says 4 groups of some number equals 16. 4 times something equals 16. Underneath it, we have the idea that 16 split into 4 equal groups equals some amount per group. We can use our handy dandy array here to help us solve. There's 2 ways we can do this. First, we can just look at our dimensions. I see 1, 2, 3, 4 rows. That accounts for this factor here and accounts for the amount of groups that we're breaking it up to. Now, let's see how many columns we have. I see 1, 2, 3, 4. 4 columns. So that means if there's a total of 16 here, 4 rows of 4 circles in each row, 4 groups of 4 circles in each group should equal 16. So I should be able to plug this in here. That means I should be able to say that 16, if these are 16 tiles, split into the 4 rows they're split into, should have 4 in each. Let's double check that this does indeed equal 16 by skip counting by 4s. Ready? Go. 4, 8, 12, 16. So it does indeed equal 16. I have a total of 16. And if I take my 16 total tiles here, I break them into these 4 groups that are outlined in these gray lines right here, I will get 4 circles in each group. That's what this number sentence here means. We can flip it and reverse it. So we know that 4 groups of 4 in each group, here's my 4 groups, there's 1, 2, 3, 4 in each group, does indeed equal 16. So we can use our array to find that the missing factor in this case here is 4. What I would mark on my paper, since y'all can't obviously mark up the screen like I've been doing, is I would just say that I needed to find out 4 times some number equals 16. And I needed to find its opposite, that 16 divided by 4 equals some number. Then what you can say you did is you just counted by 4s. Maybe you even draw circles like we practiced in the video yesterday. So you know that there's 4 rows. So maybe you draw a rectangle with 4 rows and you just go 1, 2, 3, 4, 1, 2, 3, 4. A good mathematician would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've reached 16. So in this case, we know that there are 4 rows, 4 columns. We found our missing factor of 4. This is a 4 by 4, so I know 4 times 4 will equal 16. I have 16 total circles in here. Oh, I gotta move my video. Sorry, friends. I have 16 total circles in here that when I split into my 4 rows, give me 1, 2, 3, 4 circles per row. So 4 also goes in here. That is my answer. That was like 4 different strategies to solve this one. All right, same deal as before. Although this time I didn't give you the array. So I want you to use the division and array strategy that we just kind of practiced above right here. Oops, I moved my paper. To try to solve this equation here. So you don't have to necessarily solve the division equation. That's in question 6. Yet you're just solving this. So what is our unknown factor? 4 times what number equals 36? How many go into my 4 groups to equal 36? I want you to draw an array like you just saw me do. So to start you off, I'll be kind. So 4 times what number equals 36? What you're going to do is you're going to draw your 1, 2, 3, 4 rows. Maybe you're like Miss Cupp and you have to add an extra row because you're kind of sloppy with writing. No big deal. So set your paper up like this, and you're going to put 1 in each to make your own array. Skip counting along the bottom until you get to 36. Then you're going to tell me how many went into each of your rows. So what is the dimension on your column, since you know the dimension on your rows is 4. What is the dimension on your columns? That number goes in there for question 6. Or excuse me, I'm going to give you about 2 minutes to solve this. Again, you're using the array strategy that we've already, you're welcome, set up a little bit here to solve what is that unknown factor and 4 times what equals 36. Then solve question 7. All right, 2 minutes coming up. Made the timer kind of small so you can see our previous work here, but your 2 minutes begins now. Happy solving. Remember, you are doing questions 6 and 7. And that's our time. Ooh, that's scary. You would think that scary siren always seems to get me. All right, let's rock and roll. What I do on my paper is what I hope that you hopefully did. So using our array strategy, 4 times what number equals 36? That means I've set up my 4 rows and I'm going to put 1 in each row until I get to 36. Or you can think about it even faster. And instead of putting a circle in each row, you can actually just draw a line and create 4 boxes and skip count by 4s. So you can do 4, 8, 12, because I've made now 12 boxes, 16, 20, 24. Got to extend my lines apparently. 25, 26, 27, 28, 29, 30, 31, 32. Ooh, we're getting close. I don't know why I did that there. Sorry, guys. 33, 34, 35, 36. So now I just have to count how many boxes I actually created in each row. So I know that I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I created 9 columns when I did that. If you drew circles and then created circles stacked on top of each other, that's totally fine too. I just like to think in boxes sometimes, so I wanted to reveal that strategy to you as well. So like I said, we know that in each of these 4 columns, or excuse me, 4 rows, there are 9 boxes. So the missing factor here is that 4 groups of 9 equals 36. Now, let's think about this question 7. I'm going to do it up here since I'm running out of room. Question 7 then asks us, okay, so based on the work that we did here, now that we know 4 times 9 equals 36, what division equation matches the array you use to help you solve the question? So it's saying, what division equation could you write for this array? So I know I have 36 total. I know that I have 36 total squares in here. So I'm going to write for my division equation. I'm just going to move this up so you can see me working in both. So I know that because there's 36 total, I'm going to say this was 36, and I split this into 4 groups. I split this into 4 rows to equal, and we found that there was 9 in each row. I also didn't even have to necessarily look at my array to figure this out because I could have just looked at my multiplication equation. Since I know that multiplication and division are opposites, they're opposites. I know that if I ended with a total of 36 in my multiplication equation, I need to start with a total of 36. If I had 4 groups in my multiplication equations, I need to split my division equation into the same 4 groups. And since I can't just make up my own mathematician magic, I have to obey the laws of math. Since there were 4 groups of 9 up here, when I take that same 36 total, maybe I got that 36 boxes, maybe that was a brownie that I was splitting up. So if I have 36 pieces here and I split them into 4 groups, I will have 9 pieces in each group. Just like here, because it says 4 groups of 9 equals 36, 36 split into 4 groups, we'll have 9 in each group. So lots of different ways we could use to solve that. Let's write our answers in here. So we know in this case, you should have typed 9 into here. And the division equation that matches the array, well, we know that it's this one because we just did the work, but also let's evaluate real quick. This one makes no sense because 4 split into 36, you don't have enough there. 36 split into 36 groups, that would just be 1 per group. And since we know 9 goes in here, we can really double check that this is wrong. 9 split into 4 groups is not going to be 36 in each group. If I had 9 cards and I wanted to split them between 4 friends, I would absolutely not be able to give each friend 36 cards without being a super magician and creating new cards. Alrighty, it is time for today's magic word. I'm going to show it to you, and then I will also spell it on your screen. So today's magic word is Miss Cupperell's favorite drink. If you're her friends from Hadley, you know that this is literally what I live on. The magic word today is coffee. It's in my mug right now. I'm not actually going to drink it because it's cold right now, but the magic word today is coffee. I'll spell it for you right over there real quick. But since we are done with our guided practice today, reminder that we are going to be using arrays to be solving multiplication and division equations. You're going to be using your array strategy and your division strategy, which is basically when you just split the array into rows like we did today to figure out how many go in each row, to help you find the unknown factor in some of your IP questions. If you finish a little bit early and you have some extra math time on your docket, go ahead and play some Splash Learn or some Prodigy, my friends. Have a great Tuesday.